My name is Kelly Weimer, and this is my final presentation for Forestry 375, Introduction to Spatial Analysis. I will be looking at the densities of earthworms in Washington in correspondence to the acro-ecozones. My hypothesis is that earthworms will prefer wet or fallow transition crop types, and therefore their densities will be higher in those corresponding acro-ecozones. My consensus for this is that the wet or fallow transition crop types will provide more nutrients or more water and therefore create a more sustainable habitat and more preferable habitat for the earthworms. The first data layer that I will be using is the acro-ecozone classifications for 2010 provided by David Huggins at Washington State University. The second is the biotic earthworms dataset for 2012 provided by Jody Johnson Maynard at the University of Idaho. This map shows earthworm distribution in the acro-ecozones for Northeast Washington, the more dominant acro-ecozones being the annual crop wet-cold, the less dominant being the annual crop fallow transition. The first part of my model, I took a buffer of each of the data points for the earthworms. I took a buffer of about 300 meters. I then took the acro-ecozones for 2010 and created zonal statistics as a table and combined it with the buffer I created, which then produced a final table that I would be able to look at the dominant crop type for each of the locations of the earthworms. And I would also be able to look at the densities in each of those specific locations where the earthworms were collected. The table that was produced gave me the density of earthworms at each specific collection site, but I was interested in determining the density of earthworms in each of the acro-ecozones. To determine the density of earthworms in each of the acro-ecozones, I pulled the data from the final table I created and exported it into Excel. I then organized the data to correspond with the acro-ecozones, and I calculated the average density of earthworms for all of the collection sites within each specific acro-ecozone. I then was able to create this bar graph that shows the average earthworm density per meter squared in each of the acro-ecozones. The results do support my hypothesis, as the highest average density of earthworms was in the fallow transition and the wet-cool acro-ecozones. There was no data for the earthworms in green fallow, so the density is shown as 0 on the graph. This concludes my final project for Forestry 375. Thank you for your time.